All right, so I thought I would spice things up by putting a picture of me on the front slide. I'll try to put a different picture of an archaeologist in action, using me as the key example. I'll start off with an identifiable one. All right. We're going to continue on with our discussion of excavation with a discussion of how we basically record data in the field. Now, your site director, we mentioned the different personnel. The site director, who's usually in an academic archaeology type research dig, will be the same person as the principal investigator, the professor who pitched the project. So I usually fill this role when we're in the field. But we all have a slightly different approach to doing things. But we all tend to use these basic kinds of things. You've got context sheets, which are sometimes called level forms. This is a basic form that has on it all of the things that excavators should look for. So and I'll show you an example of one as we come down the road. So I guess I don't need to say much about that right now. Plans, or also sometimes called a plan view. That's a basic map, a top-down map of the finds that each excavator makes. A section or a section map, sometimes called a profile, is a side view map, a view of like the side of an excavation unit. I'll show you some examples in just a second. We all have some kind of artifact collection system or a catalog system so that we can record the finds of a site. And I'll discuss that as we move on. And when possible, we try to organize these data with computers. I pulled that last one out of the textbook because I would not say that is something that we all have in common. There's a lot of reasons not to use computers on a site. Not the least of which is that often you are in a remote location. Often the weather is bad when you're working. So you can't always depend on having a computer. Second of all, computers are fickle things and are subject to losing data. In my opinion, everything that's on a computer that's worthwhile should have a hard copy of it somewhere if you intend on keeping it forever, or at least a backup somewhere. And you can't always make backups when you're in the field using computers. So I like to record all of this stuff on paper, and then computers are used where appropriate. Potentially, data could be entered in the evening as sort of a permanent storage device. But once you ultimately need your data on computers to be able to write papers on it and to analyze it with maps and GIS software and that kind of thing. So. Now, in terms of mapping and getting things into position, we're going to want to know where everything is with exacting detail. That three-dimensional position of an object is called its provenience. That's Provenience, provenience. So if I talk about the provenience of an object, that means, well, that's exactly where it was found. The most basic way of positioning your stuff on an archaeological site is with a tape and compass. When I say tape, I mean a measuring tape. Measuring tape and a compass. If you ever make a map of something, or if you ever want to make a map of something, and you want to get an exact, and you want to use, and precision makes a difference, the first thing you ought to do is establish a datum, a central point from which all your measurements can be taken. And once you have that, you can pretty much establish an imaginary coordinate system with, so many feet or meters north of my datum, or south or east or west. And then you can just use your tape and compass to calculate what those coordinates are. If you really want to get fancy, you can use polar coordinates and say, okay, my object that I found is 135 degrees away at 20 meters, and then but now we're getting into more complicated trigonometry, geometry, which brings up a good point. In archaeology, it's a really good idea to have a good handle on basic mathematics, geometry and trigonometry in particular. It's amazing to me that the university requires calculus level mathematics, but not those things, which are far more useful to most people. So trigonometry and geometry are what you need to establish objects in three-dimensional space. And people use those skills of trigonometry and geometry in all kinds of industries: construction, archaeology, geology, pretty much all the ologies use those things. All right, so tape and compass. A theodolite is a non-electric version of the total station, which I mentioned before. Another term that I see them using in the text is EDM. That stands for electronic distance measurer. I use the term synonymously with total station. There may be some kind of technical difference, but a total station is a type of electronic distance measurer. The difference, I guess, is that the total station has a computer built into it that records all of your measurements. Whereas the theodolite, it doesn't use electronics. It's an old-fashioned survey instrument. And again, I would probably, this is so much faster, but they're expensive. And I'm just telling you that when you're in the field and you start using electronics, they cannot be counted on always. In getting the data out of this total station can pose a technical barrier. Whereas if you have a theodolite, you're doing everything manually, the old-fashioned way, you're writing all your measurements down in a book. The problem is that's very slow. So this is one place where if I had the ability to, I would bring the total station in, because you can take 1,000 measurements in an hour. Whereas with theodolite, you'd be lucky to take 10 or 15 measurements. So, well, you probably take more than that if you're really good at it, but 10 or 15 measurements. But they both look very similar. This is a total station, I presume, because I think this device down here is a data logger, and there's a cord running down to the data logger. But that just could be a handle or strap, in which case this would be a theodolite. Okay, so let's discuss the context recording sheet. If you ever participate in an archaeological dig, you will probably be faced with this or similar recording instrument. Each director may develop their own. There is not a standardized one, but the idea is that I mentioned before, in academic archaeology, you quite often have people who are not trained or have no previous experience doing archaeology working alongside professionals. In order to make it so that everyone collects the same kind of data, you just have a form that has everything on it that they need to fill out. Works very well. And it also, even for experienced people, it makes them record data that they might forget to collect certain kinds of data. And having a form is a nice way of making it easier for everybody. The purpose of this is to write down all of the information that the excavator has. Now, next week we'll talk a little bit more about the actual digging process. But everything that they excavate out, remember, is being destroyed. So any kind of notes that they want to take have got to be on this form or some other form, but this is typically what we're going to use. So we're talking about, when it says records of layers, we're talking about, if you excavate in layers, you're keeping all that data separate. The site stratigraphy refers to the subsurface geology or pedology, which is soils. And these becoming very, very useful to us. So I'm writing up the archaeology from last season right now. And so I've got a stack of level forms or context record sheets that they're my complete record of what we did. So if you're a field director, it behooves you to check these things as people turn them in and make sure that they are detailed enough. Because a lot of time the excavators don't think it's important to write all the details, but they have to remember that it's all that we're ever going to have. I'm going to come back to this, and I'm going to talk about this real quick. This should have been up there. Look, I'm not going to ask you to fill out a form, so you don't need to know all this stuff. But I do want you to know the kinds of things that we're putting on here, because some of these kinds of things that we're recording, you're going to want to be able to discuss or talk about on a test. But I won't ask you to be able to fill out a form. Just a few of the things that I wanted to mention were, every site has a unique reference code, usually given to it by the government. GNJM32 might stand for the county or the state that something's in, and then the site number. These things are all recorded with some government body, so we put that up there. The interpretation that this is a foundation of a house. Each excavation area is usually assigned a number, so that if I have 10 or 15 excavators excavating in different places, that each of their little areas might be given a number like 5 or 6. This would be two pits right next to each other. And I might have these things gridded off into a larger coordinate system. The whole point is this is telling me exactly where this excavation unit is. And I've asked them to write a description of the soil, and this is just an example of what they might have written. Sometimes, now in America they don't do this a lot, but I find it very, very helpful that when you're excavating in layers, and you have a layer of soil that's relatively easy to identify, you can give that layer a number, like 100, 101, 102, and record that somewhere. And then when you're excavating in the next test unit over, if your soil that you're excavating in looks just like that other soil, you could write, this is the same as 101 or 105 or whatever. That's what they've done. This is the same soil as this other test unit. And if you happen to know, like if you've excavated down 5 or 6 layers and you've numbered them all the way down, and you know, for example, that layer 164 is stratigraphically higher than 105 in one test unit, then you could make a note of that right here. You could say it's below this or above this. Later means more recent. Sorry, that's confusing. But later means it comes after 164. And this is going to start to help you get a relative chronology of a site. So these are these things are very, very helpful. And the excavators know better than anybody about the soil that they're digging in. Other things, for example, when they're done excavating this level, they're going to make a map. That map gets a catalog number, which you put here, so I can associate those maps, which are a separate piece of paper, back with this. And we've talked about plan views and section views, so those will both be on here. I'll talk about colors in a second. The elevation of the site on whatever map system you're using, and your provisional time period you're giving it. This comes from a Roman era site, Roman phase 1, and then the initials and date of the excavator, so that if I have any questions, I can ask them. So these are the kinds of things that you're going to put on an archaeological level form or context recording sheet. Now, comments and interpretation, these are the opinions of the excavators themselves. If I have to, if I ask you, you're excavating something, you're excavating this Roman phase 1 test unit, or trench as they call it up here, and I say, well, what do you think is going on here? And the excavator can tell me what they think is going on. They might think it's a abandoned floor of a house, or they might think this is a cellar or they might think that it's really disturbed because they found a lot of trash, modern trash in the test. Whatever they think, just their thoughts. They put all these things here and help me remember, because I may not look at this for 5 or 6 months. So they help me later to look at and interpret what this is. So those are the kinds of things that I want you to have on these level forms. Okay, so this slide here didn't work, but let me point out what a few of these things are. This is your Munsell color sheet. Geoscientists, whether they're geologists or soil scientists or archaeologists, people who work in the dirt, they want to characterize the color of something. They have this soil booklet, which is just like a bunch of paint chips, really. And you flip through this and you try to find one that matches. So this one might be, this might be here or there, one of these two maybe. And this has a number associated with it, and you put that on your level form when you're describing your soil colors. There's an example. There's a girl here making a plan view map. Can't really see too well, but she's got a little square here that she's drawn, and she's recording this information down there. And she doesn't have a compass. She's using a tape measure. However many, I don't know, whatever this, I can't read that, but there's a tape going in both directions, and she's drawing a top-down view, same thing that they're doing over there. So these are the kinds of things that your excavators do to help make the investigator's job a little easier. I'll let you guys copy these definitions down. I put these up here because I didn't think that previous slide would work, possibly. We refer to the soil that we pull out of a test unit, the matrix. So the matrix is not a virtual reality that you live in and can be freed from with a blue pill. Or was it the red pill? Doesn't matter. That's not what it is. But that would be a clever answer if I gave essay tests. I can remember in grad school, I was asked to, I was writing essays on some anthropologists, famous anthropologists from the past. And I was supposed to identify Sorokin as a Russian anthropologist, but I didn't know that. So I put that it was Spock's father. Sometimes you can inject a little bit of humor into these things, and professors will appreciate you rather than bullshitting them, which they can see right through. Okay, so a matrix is the soil that we bring out, and which is precisely what we'll try to get a color on usually. It's this Munsell color chart. The context is, the way the textbook uses it, is the layer of soil in which artifacts and ecofacts are found. Okay, they call that the context. So your context record is your layer that you're digging in. But I would like to say that it also can refer to an object's relationships to other objects on the site. So the context of a bone might be that it's part of a burial. That's its context. And it's imperative to know the context of an artifact to interpret what it is. Because one artifact doesn't tell you what a site is usually. It's usually because of a number of artifacts and their relationships to one another that can tell us the function or purpose of a place or site. I mentioned before the provenience as an object's 3D spatial coordinate, and then I put or general position if exact position is unknown. Quite often, let's just say you're excavating and you're trying to find things where they, in place, but you shovel all your dirt into a bucket. You take that bucket over and you dump it into a screen and shake it through a screen to make sure that you didn't miss anything. And let's just say you find something in that screen, a nail or a coin, right? Now, you don't know where it came from, do you? You don't have its exact 3D position, but you know its general position. Its general position it was found in this layer of this test unit. So whatever those coordinates were that you wrote, so that's its general position. And so when I talk about provenience, I'm talking about an object's position on the landscape, essentially, to whatever specificity I can get. And then plan view, top down map. Everybody got those? So those are some of the terms that you need to know and remember. All right, I covered that. All right, let's give you some examples of some of these things I was talking about. This is an example of a section drawing, or sometimes called a profile. And you can see all of these people are doing the same thing. They're trying to draw not a top-down view, but a side view of what they've been excavating through. This guy here is tracing the layers that he sees with his trowel. I see all kinds of lines here. It looks like he's tracing sand dune. But anyway, that's what he's doing. He's tracing it out so that when he draws it, he can, it'll be easier for him to draw. I see real clearly here that there's a sedimentary difference right here. I don't know what that means, but that's a real obvious change. You can have 3 different kinds of changes in your profile, in your section drawing. You can have sedimentary changes, where you're moving from one geological layer to another. Like this might be clay, and then this might be, I don't know, sand or sandy loam or something. And it's not a gradual change, it's an abrupt change. That is an important indicator that there's an important event taking place at this contact. It could have been a erosional event, or it could have been that this was deposited on top of something. But there's some amount of time represented between these 2 contacts. The other kind of layer you can get is a soil layer. Soil forms on sediment. So if this was a fresh bunch of sediment, and plants and things start growing on it, all that organic starts to get put down into the soil, and this will turn a darker color, and you'll have a soil change with depth. And so eventually you get down to the unaltered parent material, but the whole top part of this could be different shades of black and gray or whatever have been put into that soil. And then the other layer we're interested in is, of course, a cultural layer. So you might have a layer down here that's where all of the artifacts are coming from, and that would be a cultural layer. So stratigraphy can be very complicated because you're describing all of these things, because there's going to be a soil that could go through all of it. The soil can be imprinted right on top of a cultural layer, which can be imprinted right on top of 2 different sedimentary layers. It's only been in the last 20 years, though, that archaeologists have routinely, some archaeologists have routinely gotten specialized training in sedimentary geology. And it's really been transformative in terms of helping to understand how archaeological sites are made, both geologically and culturally. So we really understand the earth a lot better now than we did 20, 25 years ago as archaeologists, which really helps sometimes. These people are just, this person drawing a piece of his or her profile there, and they have little artifacts pinned. This person's doing the same thing. So these are the kinds of things that each excavator will be expected to be able to do. Quite often, if you're artistic, you'll volunteer to do these things because it can be relaxing. But other times, everybody has to be involved. Here's an example of a complicated section drawing that has cultural materials as well as other matrices. So they've drawn on here the locations of artifacts, the ages that they have interpreted. This is a Roman era archaeological site, so they've interpreted all kinds of stuff. This is an old one from 1922, but I thought it was a pretty example. Where you find coins, you note where the coins were. You've got rubble from the interpretation is an altar. An occupation layer, this is your cultural layer. There's a cultural layer on top of this rubble. And then there's filling. This is other matrix that's been deposited on top of the cultural layer. Then there's another occupation layer up here. They have not marked any soil development, so there either isn't any or it's not relevant. They've determined that it's not relevant. Generally speaking, you can predict that the deeper layers are older than the top layers. That may seem intuitive. It's an important concept to remember as an archaeologist when you're excavating. That's why it's important not to try to mix things together. If you excavate down through 2 layers at one time, and you don't know where stuff is coming from, then you can't tell how old it is anymore. You just may have mixed 2 time periods altogether. Up here, you've got a date of 330 to 350 AD if it can be dated by the coins. And down here, this is dated at 254 to 73 AD, much older down here. So I find it interesting that down here you've got coins of 193 to 230 AD beneath it. That's going to tell you that this whole area is mixed up in here, because there's older coins down here below. I mean, the oldest coin, 73 AD, is up in here somewhere. So using coins to date stuff is problematic. But archaeologists try to do it occasionally. A better way to date this would be through radiocarbon dating, which we'll cover at some point. The radiocarbon dating was not invented in 1922, so it wasn't around. So they did their best with the tools that they had. Is that all I have? Holy smokes. All right. So